So children, welcome to the video 3 in connection with the video 1 and video 2. If you take up all the videos in serial, you will be able to understand electricity very well, the basics of electricity very well. Now let us see, we talked about potential difference. So how do we create potential difference? One of the methods to create potential difference is using chemistry. So we know we take an acid dilute sulfuric acid in a beaker and we place copper plate and zinc plate, and we leave two open wires so that externally we can connect anything, any device over there. Now have a look. What will happen? By nature, when you study acid, bases and salt, you'll know acids that dissociate. So acid will dissociate. Now here H2SO4 will dissociate into hydrogen ion and sulfate ions. So there is a sign which is relating to some of the molecules will dissociate and some of the ions will combine. So it's a dynamic equilibrium. The acid, when it is kept in a beaker, it is undergoing a process of constant dissociation and again joining over there. That is your chemistry chapter. But anyway, now what happens when the plates are there, the sulfate ions will move towards the zinc plate and they will neutralize, forming zinc sulfate, and they will release electrons. So the zinc plate is having abundance of electrons. That is why it is in negative potential. Abundance of electrons means negative potential or low potential. Now, so the zinc plate will have negative potential, that is low potential. The hydrogen will move. You know, in the reactivity series, hydrogen is above copper, so it can take electrons from copper and neutralize itself and leaving copper plate positively charged. So the copper plate comes at a high potential. Now see, it is not joined. So now this is electricity at rest. Electricity at rest. It's almost both the negative and the positive plates are looking at each other and the electrons are ready to move in case they get any way. So that is how you get your cell. It is written 6 volt or 7 volt potential difference. The cell is exactly like this, except the electrolyte over here is liquid. You get a dry electrolyte, so semi-liquid type electrolytes. In some of the cells you'll get ammonium chloride. In the recent cells these electrolytes have changed. But the basic fact is the same, creating potential difference. There are two plates. Now as soon as we join the plate, electrons will move from zinc plate to copper plate. When both plates are connected, electrons will flow from zinc plate to copper plate. So electronic current has a direction to flow from low potential to high potential. But conventionally we give the direction of the current from high potential to low potential. That through the process again you will be able to understand. So that means now the chapter has converted from electrostatics to electricity. What is electricity? It is a flow of charges. See, there are charges flowing. Sulfate ions is flowing inside. So in a liquid the ions flow, sometimes electrons, but ions flow, and hydrogen is flowing the other way around. So that is also current. Current can flow in liquid also. Flow of charges will constitute electric current. If somebody tells you to define what is electric current, here only you have understood electric current. Flow of charges constitute electric current. Flow of charges across points having potential difference constitute electric current. In metal wires normally the current is due to the electrons movement, and in liquids it may be due to ions or it may be due to electrons as well. So that is what is there. Now what is a qualitative definition of electric current? Flow of charges through a conductor which is connected to terminals having potential difference. Now suppose 50 coulombs of charge is moving in 5 seconds across the cross section of a conductor. Calculate electric current. So it's very simple. Calculate electric current. It's very simple. So current will be I is equal to Q by T. That means 50 by, this is in seconds, so 10 coulombs per second, and unit will be 10 ampere. Unit will be 10 ampere. So that is very important. So there is a qualitative definition. What is electric current? If somebody wants to explain, ask you, then you say, see, we create potential difference. There are electrons ready at the zinc plate, and there is scarcity of electrons at the copper plate. And then what happens when the current flows through the conductor? When the current flows through the conductor, then what happens? Electricity or electric current flows. So electricity is basically flow of charges. In liquid it is ions, and in wires it is electrons. How much is the quantitative definition? So if 50 coulombs flows in 5 seconds, then in 1 second it will be 10 coulombs. So the rate of flow of current is 10 coulomb per second, and coulomb per second is the current. So the unit, SI unit of current is either coulomb per second or it is ampere. And we basically measure the current by using a device called ammeter. Ammeter can be connected, and it's a ready-made device from where you can measure the current. So thanks a lot.